Let's take a look at the serial communication blocks in the telediagram program together. In the current project, we will examine the RX packet, TX packet parser, and serial gateway blocks. We will parse the packets of the device connected via RS-485 on the serial port block. Here, settings such as baud rate, data bits, parity, and stop bit are made from the serial port block object properties. The output of the serial port block is connected to the input of the RX packet block. From the object properties of the RX packet block, the method by which the incoming packet should be parsed is determined. In this example, the packet start packet end parsing method is selected. The frame timeout period determines the size of the area in bytes. For example, we open a 10-byte area. Start a frame and end a frame, what are they? In the example we will send a 10-byte data with a start frame of 41 and an end frame of 42. In this application, we made an example by connecting the RX packet with the packet parser. From the object property, we said to read a 2-byte value from the 0th index for one of the packet parsers. Then, for the other one, we started from the 2nd index and read a 2-byte value. Then started from the 4th index and read a 2-byte value. Finally started from the 6th index and read a 2-byte value. This way, we will parse the current packet byte by byte. First, let's upload the project we made to Let's reconnect to the device for testing. Let's start live monitoring and observe the data. Now, in the assistant program, we will first send the packet to the relevant field. We define a value with a start frame of 41 and an end of frame of 42. We started with 41 in hexadecimal format. In the study we will send a packet with a Let's also assign another variable with a start frame of 41 and all other intermediate bytes being 0.0. We entered 42 for the end of frame and Now we will evaluate this with online monitoring. When we send the packet, as seen, the values are entered here. The value sent here can be checked with a calculator. Thanks to the packet parser block, we parsed the incoming packet byte by byte and transferred it to different blocks. When we press reset, we see that the blocks are immediately reset. In the next application, we will look at the TX packets. In this application, we will send these packets as TX packets by defining string references. Here, you can choose options such as append value type as ASCII integer, ASCII float, or binary integer bin float if you wish. We selected We performed value index assignments from 0 to 2 bytes, from 2 to 2 bytes, and from 4 to 2 bytes. Now, here we use text reference blocks to write the values. To define the string offsets within the text reference, we will enter the inputs of the text values we will send in the text table area in the projects section. Let's write test to one of them. Let's send 123 numerically to the other one. We also assigned microdef to the third one, that is, we entered the string content. And we select these in the relevant text reference. Let's upload the project to a device in this way and test it. After the upload process is complete, we connected to the device via TCP again. Here, we connected the trigger input of the blocks we will send to the binary register. During the pulse duration, it will transmit the changes here to the system as TX packets in text format. That is, it will transfer them via 485 to the connected system. Let's send one from the binary register. We activated the trigger. Let's look at the other side. As seen when converted to ASCII format, it sent these packets by combining string references. Test 123 microdef. I will send a pulse again to show it. Let's see them both on the screen at the same time. When I send one to the trigger input, as seen on the screen, it sent the TX packets. Now let's move on to our other block, the serial gateway block. The serial gateway block is used in transparent communication systems. The serial gateway block allows the packets of a device connected via RS-485 or RS-232 to be directly transported to remote systems via Ethernet, GSM, or Wi-Fi without performing any operations. We connected the serial port block to the local input of the serial gateway block. Let's do our tests by opening port 500. Here, we will view the data we send via RS-485 over Ethernet. And let's do it the other way around. First, we open the RS-485 port you see on the right side of the screen. On the left side, let's connect to the device's IP and port address as there is a connection on both sides now. Let's send a value, for example, ABC, and read from the other side. So, we transparently transferred the data. Let's do the opposite. When we send a value over TCP, this time we see that this data is transferred over RS-485. You can also communicate transparently using the serial gateway block in this way.